Welcome to Unit 1, Functions, Properties, and Rates of Change, Lesson 6, Average Rate of Change, otherwise known as the AROC. My learning goals today, I can and will find the average rate of change between 2 points given a graph or an equation, and I'm also like to add a little bit, and I'm also going to interpret that average rate of change. Alright, so here we go. Warm up my first thing. Since average rate of change is just kind of an addition to slope, first thing I'm going to do is I'm going to find, as a warm-up, find the slope of these 2 points. You can do this on your own. I'm just going to go through it with you though quickly. For the first graph, choose 2 points. I've got a point here on the y-axis of 0, -2, and I've got another point here at 4, 1. Record those 2 points. Once I got those 2 points, y2 minus y1, so 1 minus 2 over x2 minus x1. 4 minus 0. So here I've got a slope of -1/4. Of course, it's negative because it's going down from left to right. Next one, I can use the y-intercept 0, -4, the x-intercept 6, 0. Record these 2 points. Do I need to record them? No, but there they are. Once I record those points, then I put them in my slope formula, 0 minus -4 over 6 minus 0. Of course, that is a double negative, so it becomes a positive, so it's really 4 over 6, which is 2 over 3, positive slope y going up from left to right. Next one, special case, choose 2 points. I again will use the y-intercept, and then again I'm going to use a point over here, so 0, 5, and it looks like 5, 5. Horizontal line, slope of a horizontal line is always, from your grade 9 notes, 0. Over here, I got a x-intercept, sorry, of -5, 0. Use another point here. There you go, of -5 and 3. It's a vertical line, and recalling our grade 9 class that a vertical line has a slope of undefined. Alright, so slope is also known as average rate of change, but put in the context of units. So for instance, what are some units I can have? Kilometers per hour, dollars per liter, meters per second. You can think of some others. Formula reminder for slope. M is equal to y2 over, or y2 minus y1 over x2 minus x1. However, we are really going to focus on this slope formula today, or average rate of change formula today. It is the same formula. However, it's now function notation. Instead of y2, it is f of x2. y1 is f of x1. All right. Now, as I said before, we are going to find the average rate of change, but we're also going to put things into context. So by putting things in context, we need a therefore statement. And to write a therefore statement, this is interpreting our answer. And this is at least where half of your marks are going to come from for AROC questions. For an average rate of change question, the therefore statement requires 4 things, and I apologize about this. This is rather embarrassing. But this should be not this 4, but the number 4. All right, Mr. Wills. I am sorry. What do they need? They need the reference point. So the reference point, reference point, not a reference point, but a reference of time. So between what times? So here, what times does this occur? Or at what time? That's for lesson 7. That's for tomorrow's lesson. So really, reference point. Subject, what is happening? What's the object? What's moving? Direction, which direction is it moving in? Up or down, left or right, etc. And finally, rate with units. So this is your answer right here. This guy right here, that's your answer. And then with units. So these are the 4 things we need from a therefore statement. From it, you're going to see that the math is actually the easy part. This is the most important part right here. We're going to use this in lesson 7 as well, and lesson 8. If you don't have this, you will lose half your marks, and these are silly marks to lose. All right, here we go. First example, I'm going to go from a graph, and I'm going to get the equation here, or not the equation, but I'm going to get my average rate of change. So Nicole crushes a baseball. Its path is modeled by the graph below. You can see that our horizontal axis is time, our vertical axis is height, and we are going to find at 1 second the height of the baseball was. How did we do that? Pulled up the line too fast. Where's the dot? But we can see here that at 1 it is 10 seconds, and at 3 it is 18 seconds. So record those 2 coordinates, 110, 318. Next thing I do is I actually find the AROC, and notice again here, instead of writing M here, I write AROC of 1 to 3. So that's a nice fancy notation of how to write the AROC. Again, a rock 1 to 3, y2 minus y1 over x2 minus x1, and there we go. And so we get a slope, or we get an average rate of change of 4, which is a slope of 4. Again, you can see that on the line as well. So therefore statement, here we go. Therefore, between 1 and 4 seconds, so I'm going to highlight the 4 important points here. Time, 1 and 3 seconds, sorry. The ball, the object, ascends, so it goes up at an average velocity. So again, units of 4 meters per second. So there are the 4 things that I need. I'll highlight it. Let's try the next one. Here's the next one. Again, 1 and 3, so here's 1. Oh no, I'm doing 2 and 4, sorry, to find there 2 and 4 seconds. So I'm going to put a point at 2, point at 4, and I'm going to draw a line through it. So with the slope of that line, of course, we can tell right away that is actually a horizontal line, so we can find the average rate of change is just going to be 0. How do you write a therefore statement for this one? Therefore, between 2 and 4 seconds. So let's go again. Time, the subject, the ball, has an average velocity of 0 meters per second. Where's the direction? Well, there is no direction here because the ball is neither going up nor neither going down. Overall, in that time, it is, but the average is not, so we don't actually put the direction for that one. All right, last one. Between 1 and 6 seconds. All right, so 1 and 6 seconds. So again, I'm going to find my points. There's 1, there's 6 way down here, and then I'm going to draw a line through it. And what's the slope of this line? So again, I found my 2 points. We already found the one 10, and then the other one 6, 0. Again, notice my A rock on 1 to 3, so not M, but A rock is -2. Since it's negative, it's not going up, but it is going down. So I write therefore statement, therefore between 1 and 6 seconds. So again, time, subject, the ball, descends, direction, at a average velocity of 2 meters per second. Please note a few things here. Descends, not ascending, not going up, but going down. Now, if you want to say going down instead of descends, that's absolutely fine. And notice how my average rate of change is not negative here. It's positive. It will always be positive. The direction is telling me whether it's going up or down. So, or whether it's positive or negative. Now, another thing here is secant. What's a secant, Mr. Wills? A secant is actually this line right here. The secant is a line that goes to the 2 points. So what I just highlighted here, that is a secant. So a secant is a line, not there, perfect, which passes through 2 points. I'll have to write it in. All right, so a line, my pen is broken, so I am trying to write with my finger right now, which passes through points on a graph of a relation. It's terrible writing there, but there it is. Oh, it's right here actually. Let's try it again. So a secant is a line which passes through 2 points on the graph. So here, this red line, here's the function, this blue line. The red line is a secant because it passes through 2 points. Tangent, Mr. Wells, what's that? We'll learn about that one tomorrow. And then finally, let's do an equation. So again, Nicole crushes a baseball. Its path is modeled by the equation h of t is equal to -2. X minus 3 squared plus 18. So there's a really important point here. Our equation is right there. Determine the average rate of change between the interval 1 to 3 seconds. So what do I do here? The first thing I want to do is I want to find this. I want to find the A rock between 1 and 3, so h of 3 minus h of 1 over 3 minus 1. There's my equation. Well, Mr. Wills, what is h of 3 and h of 1? So I take my highlighted equation over here, this guy, and what I'm going to do is I'm going to plug in 3, and I'm going to plug in 1 and find those y values. So I do that here. So h of 1, where I see a x, I plug in, that really should be, the equation's not quite right, there should be a t there. Anyways, I plug in a 1 for x, and then solve. So -2 times 1 minus 3 squared plus 18, I get 10. h of 3 is equal to negative 1 minus 3 squared, which of course is 0 squared, which is still 0, so I get 18. Plug it in my equation like I did before. So 3 minus 1 is 2, so in the denominator I've got a 2, and 18 minus 10, so that's going to be 8 over 2, which is actually just 4. Write a therefore statement, therefore between 1 and 3 seconds, the ball, the subject, again, ascends. Direction is positive, so it's going up, at an average velocity of 4 meters per second. There's the first one. Let's try the next one. So here I want the AROC between 2 and 4 seconds. So the nice thing is here, well, not really nice thing, but here's my equation, right? AROC, subscript 2 to 4, so h of 4 minus h of 2, so instead of y2 minus y1, and then here I got 4 minus 2, those are my x values, and the x values are given in the actual equation, or here are the t values, so plug it in. H of 2 is equal to 16, h of 4 is equal to 16 as well, oh, that's nice, and so I'm going to have 16 minus 16, which is 0 over 2. So my AROC here is 2. And then I write my therefore statement, therefore between 2 and 4 seconds. So again, let's highlight what I have here. 2 and 4 seconds. The ball, subject. There is no direction because the average rate of change is 0, but I still write the average velocity is 0 meters per second. That was poor highlighting. There's no blue here, which means there's no direction here because the average rate of change is 0, so it's neither up nor down. All right, let's do the last one. And hopefully you see that the actual equation from the graph and the equation actually match. So I'm really just redoing these questions again. Here 1 to 6. So again, first thing I do, here's my equation. AROC from 1 to 6 is h of 6 minus h of 1 all over 6 minus 1. Again, fancy way to write slope. I find what these two values are. So I find that h of 1 is 10 by plugging in 1 in for x, and h of 6 is 0 by plugging in 6 for x and solving. Put in my equation, 0 minus 10 is negative 10 over 5 is negative 2. Since my average rate of change is negative, that means the ball is not going up, but is going down. So I write a therefore statement about that. So again, here we go. Between 1 and 6 seconds, there's the time, the subject, the ball, descends, direction, has a direction, it's negative, so it's going down or descends at an average velocity of 2 meters per second. I shouldn't see rate of change of 2 meters per second. I should see average velocity. This is a velocity question. Why? Because it is distance per time. All right, that is the lesson. Homework, I'll talk about homework if you want it. It's not in the package, but it is in Google Classroom. So there it is. First one is pretty straightforward. Question 1, you're just finding multiple average rates of change. Question 3, you're just finding the average rate of change given the function f of x and g of x. Discuss how the average rate of change for the two differ. It's kind of a nice question, actually. Oops, I didn't mean to highlight. 6, what's the average rate of change? They give you a function. And then 8, what is it asking? Population, thousands since 1950, and it asks you different questions here. So again, it gives you a table of values, and then you're just finding it between the different times of the year. That's it. Thank you for listening, and I apologize about the quality.